Well, hello Internet, and welcome to part 12 of my Learn to Program series. In this part of the tutorial, we're going to do a lot of advanced things with functions. I'm going to cover how to use functions as objects, function annotations, lambda or anonymous functions, map, filter, reduce, and I'll have a whole bunch of problems for us to practice with. If you haven't watched any of the previous parts of this tutorial, I provide a link here in the video to the complete playlist, and you should definitely start from the beginning. And in the description underneath the video, I have a link to all of the code that is heavily commented, as well as a transcript from the video, and I have a lot to do, so let's get into it. Okay, so here we are inside of PyCharm. So the very first thing I'm going to do is I'm going to create a function, and I'm going to call it multiply by 2, and it is going to receive a number. And I'm going to show you a whole bunch of different ways, maybe odd sort of ways we can use functions. First off, we're going to be able to, well, let's go in here and finish this up, and it's just going to multiply this times 2. We're going to be able to assign them to a name. So let's say I create a variable called times 2. I can assign the function I just created to it. So multiply by 2, and we can just chop that part off right there. And then what I'll be able to do is come in here and do a print, and we can say something like 4 times 2 is equal to, jump out of here, and then go times 2 like that, and pass a 4 inside of it, and you can see right there, 4 times 2 is equal to 8. So that's one way to use functions. Another thing you can do is pass a function into a function. So let's create one. Let's just call this do math just to keep it simple. And you can see I'm going to pass a function inside of here, and I'm also going to pass in a value for that function to operate on. We can then refer to our function just with func, because that's the way we define it in the attributes. And then we can come out of here and say something like print 8 times 2 is going to be equal to, and then we can call do math up here and then pass in our multiplication function inside of there, but we're just going to pass it in by name and then pass in the value of 8. And if we run that, you can see right there it comes back as 8 times 2 is equal to 16. So another neat thing we can do with functions. Let's do some more. Let's create, first off, I'm going to return a function, and on top of that, I'm going to make this be a dynamically created function inside of a function. So pretty cool stuff. And you should practice and create your own functions here to really get this stuff down. So I'm going to say multiply by num, and let's say that I want to pass in a value inside of here. And then I'll dynamically create a function that's going to receive this value up here for num, and then return the entire function and perform a custom multiplication on it. So let's go and define another function inside of this function. So let's just call this multiply by, and it is going to receive a value, and then it is going to do a calculation based off of the number that was passed into this outside function that surrounds it, and then multiply that times value. So you can see it's dynamically creating this guy. And then we will come in here and return multiply by, get rid of that part right there. And then let's come down here and I'll just say generated function is equal to, and I can go get function multiply by number, and inside of this guy pass a 5 inside of there. And we'll see right here that we're going to be able to say 5 times 10 is equal to, and then come out here and say generated function, and then pass in the value of 10 inside of our generated function and run it, and you can see indeed that works. So that's how we can create a dynamic function, and also how to return a function from a function. So all pretty cool stuff. Another thing we're going to be able to do is come in here and embed a function into a data structure. So let's just leave all those functions there on our screen, and then we will store them inside of a list. So I'm going to call this list of funcs is equal to, and we can throw our times 2 inside of there, and we can also throw our generated function inside of there. So here is the times 2 function, which is going to multiply times 2, and then the generated function also, which is this guy right here. And we can come down here and we can actually run these. So we can say something like print, and 5 times 9 is equal to, and then we can refer to these using the list itself. So we can just say 1, and then inside of here let's pass in the value of 9 into said function and run it. and you can see indeed that it came through and was able to print that. And we'll get more into storing these inside of lists later on and doing some cool things. But now it's time for us to do our very first problem. Alright, so what I want you to do here is to create a function that's going to receive a list and a function. The function passed is going to return true or false if a list value is odd, and the surrounding function will return a list of odd numbers. So basically we're going to have one function that is going to be used to determine if a number is odd or not, and I'll give you a little hint, you can use modulus to do that. You are then going to pass that function as well as a list into another function, and then you're going to use that function against that list to generate a list of just simply odd numbers. So you can pause the video here right now and try that out. Otherwise, I am going to create it for you. Alright, so we can come in here and we can say, is it odd? And it's going to receive a number. And to find out if the number is odd or not, we're going to come in here and go num modulus 2, and if that is equal to 0, that means it is a multiple of 2, which means that it is definitely even. So in that situation, I will return false. Otherwise, I will return true. So there's that function. It's going to tell us if it's odd or not. Now I'm going to create another function that is going to come in here and create our list. That is going to be a list of odd numbers. So we're going to get a list passed into it as well as a function, and it's going to be this function right here. We're going to generate our odd list that we are going to throw a whole bunch of odd numbers inside of, and then we're going to cycle through this list and determine what is odd and what isn't odd. So we're going to refer to our isItOdd function by going if func and I. And if that comes back as true, we're going to call append to throw that number into our list. Otherwise, we are going to return our odd list after we have cycled through all of those different numbers that are available to us. Now all we need to do is to create our list. So I'm going to go create a series of values from 1 to 20, random values. And then I can come in and say print, change list, and then inside of here we want to pass the list as well as our function isItOdd. And if we run that, oh, gave me a little bit of an error. Let's see what I did wrong. Oh, PyCharm's auto completion messed me up there. I want to get rid of that. Whenever you're passing the function, you just do it by name. You don't put the parentheses after it. And run it, and you can see indeed that that list that it received from 1 to 20 was converted to just the odd numbers. So hopefully you got that right, and if you didn't, that is perfectly okay. The whole idea here is just to show you a whole bunch of common problems so that whenever you see them in the future, you will be able to solve them. And now we're going to jump over into something a little bit odd, and it is called function annotations. Now it is possible to define the data types of attributes and the return values with things called annotations. But just be aware that they're going to have no impact on how the function operates, but instead they're mainly used as documentation. Just wanted to cover them just so that I can say that I've covered pretty much everything. So we can come in here and we can generate a function, and we can say that name is going to be a string, and age is going to be an integer, and weight is going to be a float. And then we can also come in here and say that we are going to be returning a string. So there is a function with all of the different annotations. We can then come in and we can print out the name, and you can also do it with all the other different values. And I'm going to show you that it can work, but also that it can be broken. Like I said, this is for documentation reasons only, and it isn't necessarily something you can rely on. It's not enforced, but it does have its uses. Okay, so we'll just go wait and wait, and then we can come in here just so we have output that we can put on the screen, and we can say something like blank is blank years old and weighs blank. And then of course we're going to use format here to throw in the proper information, and that's going to be name, and it's going to be age, and it's going to be weight, and that's what our function does. And then we can come in here and say print and call random function to execute, and we can pass in good data inside of here. We can follow the rules that we have set, and 5.5, but just know that you're not going to get an error if you would come in and do the same thing, print and random function, and then let's just throw in 89 and Derek and Turtle, just to throw some complete nonsense inside of here. And another thing we can do, just to show you the last thing we can do, is print the annotations out on the screen. So we can just go random function, get rid of this part, and then go 2 underscores, annotations. Let's go in here and throw a turtle inside of there and run it. And here you can see. If we run this, you can see all of the output that came out on the screen, but more importantly, you're going to see 89 is Derek years old and weighs turtle. So complete nonsense. And here in this situation, you can see whenever the information goes in there properly, it makes more sense. But in fact, you can break the annotations and do whatever you want. So there are function annotations, and now I'm going to jump over into something a little bit more interesting, and those are anonymous functions using Lambda. Now, Lambda is very similar to define or DEF or whatever you want to refer to it as, but rather than allowing you to assign a function to a name like you do with define, Lambda instead is just simply going to return it. And because there is no name, that is the reason why Lambda functions are also known as anonymous functions. However, you can assign a Lambda function to a name. So it'll make more sense when I show you a couple examples. Now, the basic format of a Lambda function is you're going to have Lambda, and then you're going to have argument 1 and argument 2 and as many arguments as you want after that. And this is going to be followed by a colon. And then you're going to have some type of expression that is going to use the arguments in one way or another. So let's come in here and just go and create one, and they'll make a whole bunch of sense. So let's say you wanted to, like I said, you can assign a Lambda to a name. So let's say you want to come in here and create a sum function. Remember, it's going to receive 2 attributes, x and y in this situation. They're going to put a colon down inside of here, and then you're going to follow that with whatever you want to do with those 2 attributes, which in this situation is to add them together. And you may ask yourself, well, why would you ever use lambdas? Lambdas are used whenever you need a small function, but you don't want to junk up your code with a whole bunch of temporary function names that may cause naming conflicts among other different issues. So there we go. We've got that all in there, and now let's use it. We can just come in and say print, and then we can say sum, and call for this to execute. So 4 and 5, and run it, and the sum comes back as 9. You can see exactly how that works. Another thing we can do is use a ternary operator to see, for example, if someone can vote. So let's just come in here and we'll say can vote is going to be equal to lambda, and it's going to receive an age, and it's going to return true if age is greater than or equal to 18, else it's going to return false. And this is going to allow us to come in and just quite simply say can vote, and then call for can vote, and then we'll pass in 16, for example. And if we run it, can vote's going to come back as false, and if we change this to 19, you can see that it comes back as true. And let's do a couple more examples here. You could also create a list of functions. So let's say we wanted to create a power list that's going to convert these to different powers, convert numbers to different powers. So let's come in and go lambda. It's going to receive x, and it is then going to take x to the power of 2. And let's come in and also, well, before we go out of that, let's do the same thing here for a couple other ones. So copy that like that, and we'll do to the power of 3, and then we'll do one more, and this will be to the power of 4. And now we'll be able to refer to these functions that are inside of these lists. So let's say I want to run these different functions against one value. I can say for func in and power list, and then I can just come in and say print and call whatever the function is times 4. And you can say that it went and ran each one of those functions against the one value that I passed inside of it. Another thing we could do is we can store lambdas inside of dictionaries. So let's say that we wanted to add some type of random information. Remember a million years ago whenever we created the warriors that fought to their death? Let's say that we wanted to have some type of random information that pops out on the screen whenever the warriors fought against each other. Well, we could go and create a dictionary, and we could say quick is going to be an option, and then inside of here, colon, and we could throw our lambda inside of here, and this guy is just simply going to print out quick attack, And then we're going to do this for a couple other ones. So let's go and copy this. I guess it's not a million years ago that we created our warriors that fought to the death. And we could also do another one. This would be a power attack. And then we could do another one. And in this situation, we could have a situation in which the warrior missed the attack. Kind of neat. We could then come in and go attack and pass in quick to get just the quick function to execute. But like I said, we want to do this randomly, and we can also do this randomly. We need to import our random module here, and then we could go attack key is going to be equal to, and random. Here I'm going to use random choice, and what random choice is going to do is pick a random value from a list. So I have to come in here, and I'm going to have to call list on this dictionary to convert it from a dictionary into a list that we'll be able to search through and grab a random value from. And then I can call keys on this guy, and keys is going to return an iterable so that we can convert it into a list. And now the cool thing we can do is go attack and then call for attack key, and the attack key part is going to be randomly generated and run a function on that. And if we run it, you're going to see power attack shows up right there, quick attack shows up right there, quick attack again, missed attack, and so forth and so on. So that's a very easy way to come in here and randomly generate a whole bunch of random things and just throw them in, and it adds all kinds of diverse options to your objects or whatever you're working with. So pretty neat stuff. And now it's time for the next problem. And remember this guy and the problems that are coming up here. Somebody asked me this question just the other day, and I wrote the code, and I thought, boy, that would be a fun little problem to come in here and cover in my tutorial series. Basically, the question was, the student wanted an easy way to generate a list of heads and tails, and then to quickly go in and calculate how common the heads and tails were from the random value generator. So what I want you to do is create a random list filled with characters, either H or T. And those, of course, are going to represent heads and tails. And you're going to output the number of heads and the number of tails. And here is your example output after it's all ready. So you can jump in there and try to do the problem yourself. Otherwise, I will go in and do it for you. So what do we have to do here? Well, we know we're going to have to create the list that's going to hold all the heads and tails inside of it. We also know then that we're going to have to populate the list with 100 H's and T's. What else are we going to have to do? Little hint here, you're going to use choice for that guy right there. And then finally you're going to output the results. So pretty simple thing. So let's go in here. First we'll create our list. You can call this whatever you want. I called this flip list. Then you need to populate the list with 100 randomly generated H's and T's. So I'm going to say for I in range 1 through 101. Whenever you're trying to solve these problems, feel free to use Google to come in there and try to help yourself along. Just don't search for the specific problem because it might exist somewhere on the internet. Instead, look for ways to populate a list with a whole bunch of random values. Okay, so something to do. Perfectly fine to go and use Google if you get stuck. So we'll go flip list is going to be equal to, remember I said we wanted you to come in there and use random choice, which I just talked about earlier. And then inside of here we can throw an H, and also we can throw a T inside of there. And then of course you're going to have to output your results, which very simply we're just going to say heads and then call flip list. And we want to count the number of heads. So you're going to have to look back through what we previously did with lists and things like that in your previous tutorials if you can't remember this stuff. And here we will do tails. And I don't expect you to remember all this stuff either. And if you do that and run it, whoop, forgot to go and import my random. It's random and run it. And you can see right there, first time through, almost came to 50%, 52 to 48. Run it again, 42. Look at that. Almost always comes in very, very close to 50-50 no matter how many times you do it. And of course you could take this up as big as you wanted. And let's do 1,000, and there we are, and there we are, and there we are, and there we are. So pretty cool thing and pretty fun little problem. And if you didn't get it, that's okay. We learned something new. And now let's jump over and cover something really cool, which is the map function. Now map is going to allow us to execute a function on each item in a list. So what we're going to do here is, let's say we generate a list, and we'll just call this 1 to 10 is going to be equal to, and we're going to use range, of course, throw a 1 inside of there, and 11. And then we'll have to create the function we are going to pass into the map function. So I'm going to call this double num, just to make something pretty simple. So there's double num, and of course it's going to return whatever the number that was passed into it was times 2, and not 82 times 2. There we go. So now we can come in and we can say print, and we want to convert whatever the results of the map were into a list. So we're going to throw a list inside of there, and then we're going to go map, and then inside of map we're going to pass in a function, and double num is going to be the function, except get rid of that stuff right there, the parentheses. And then we'll pass in 1 to 10 inside of there as well. And if we run it, you're going to see that it went in there and took all of those values from 1 to 10 and multiplied them times 2. So pretty cool stuff. Let's do a couple more things here with maps so you get a little bit more used to it. Now you're also going to be able to do the same thing with lambda. Instead of passing a function in, you can put the function directly inside of there. So let's go in here and we'll say print. We need to convert this into a list, and then we'll have map, and then inside of it we'll have lambda, which is going to receive x as a value, and this time we'll multiply everything times 3. Come outside of the lambda part right there that's inside of the parentheses, and we'll go 1 to 10 like that, and run it, and there you can see we were able to multiply everything in the list times 3 in that situation. So pretty cool stuff. And another thing we can do is actually perform calculations against multiple different lists. So let's go and generate a list here. I have to call list on this, call map on that, and we'll come in and do another lambda inside of here. It's going to receive x and y. It's going to add those two values together, x plus y. Come outside of the lambda section here, and we will perform calculations on two lists. So we can come in and we can separate our lists we want to perform the calculations on just by throwing a comma inside of there and a 3, and then we can come in and print a list out on the screen. And there you can see what it did here was added 1 to 1, got 2, 2 to 2 to get 4, and 3 to 3 to get 6. So cool stuff we can do with map. Now let's jump over and check out filter. Now filter is going to select items from a list based off of a function. So let's say we want to print out the even values from a list. Well, we'll go in and create print. We need to generate a list in this situation, and here is the filter part. Let's go and throw a lambda inside of here, and it is going to receive x as a value, and we want to find out if it is going to be an even value or not. So we're going to go x and modulus 2, and it comes back as 0 for that. We know that it is a multiple of 2 and it's an even value, and then we can throw a range in here. Let's say we want to go 1 to 10, that's how we do it, and run it, and you can see that it went into that list and just pulled out only the even values. And with that information, why don't we go and create another problem. For our next problem, I want you to find multiples of 9 from a random 100 value list that is going to have, and the items inside of the list are going to have values between 1 and 1000. So pause the video right there unless you want a couple hints in regards to how to do this, and you can try to solve that problem. Otherwise, what are we going to have to do in this part? We're going to have to generate a random list, and you can do that with random int between 1 and 1000, and of course you're going to use range to generate 100 values, which is what I want to generate, and then after that you're going to use modulus to find multiples of 9 by passing that list into your function. Alright, so that should be enough of a hint right there to be able to create that. Otherwise I'm just going to do the code right now. So I'm going to go and create a random list, and we can say list, and I can call random followed by random int, and I want to generate values between 1 and 1000, so I'm going to put 1001 inside of there, and I'm going to say for I in range of 100. So I want to generate 100 random values between 1 and 1000. That's what that guy does right there, and it's giving me an error right here because I need to import random. Okay. Okay, so we got that all set. Anything else I need to do? No, that's good. Alright, so now I'm going to come in here and I'm going to use filter. So we're going to generate a list and I'm going to use filter and let's throw a lambda inside of there. You don't have to throw a lambda inside of there. You could just create an outside function. Sometimes that's preferable because this kind of gets a little busy sometimes. And we want to find out if it's multiple of none and throw 0 inside of there, and then your random list is what you're going to pass inside of filter, and we're going to basically run this comparison right here based off of all the different values inside of there. And if we run it, you can see that it jumped through there and generated a whole bunch of values, and sometimes it gets more and sometimes it gets less. So kind of neat little example right there. And now to finish off the tutorial, we're going to cover reduce. Now reduce is going to receive a list and then return a single result. But to use reduce, we're going to have to import it. And it is in function tools, and specifically we want to import reduce. And let's say we want to add up the values in a list with reduce. How could we do that? Well, we just call reduce. We don't need list here because we're not returning a list, we're just returning one value. And we could throw lambda inside of there and x and y, and then add x and y together. So that is our function we're going to be using. And then we can throw a range inside of there. Say we want the values from 1 to 5, throw 6 inside of there and run it. And you can see we got the sum that we were expecting, which is 15. So there you go, guys. That is a lot of information on advanced things you can do with functions. Of course, go in there and run your own examples and test a whole bunch of things to really get this stuff ingrained in your head. And just like always, please leave your questions and comments below. Otherwise, till next time.